This is section 4.2 from the handout or Pearson book, standard form of a quadratic function. The standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a is not equal to 0. Now, just as a reminder, this is pronounced f of x, and f of x is actually the same thing as saying y. It's just another way of writing the output of a function. So let's look at a quadratic equation, which is already in standard form. So in example 1, what are the vertex, axis of symmetry, maximum or minimum value, and range of y equals negative 3x squared minus 4x plus 6? Well, let's start with the fact that a is negative. When a is negative, and a less than 0 is another way of writing negative, the parabola is going to open like this, like an upside down U. That means that its vertex is going to be at the top of the graph. Well, that's called the maximum. The maximum occurs at the y value of the vertex. So we're going to have to find out what the vertex is, and the y value will tell me the maximum. The axis of symmetry is a line that goes straight through the middle of the graph and passes through the vertex. Now, I'm also going to show you how to do this on the graphing calculator, but for the purposes of this video, we're going to talk about how to do these problems algebraically. The way we're going to start this is we're going to find the axis of symmetry first. I'm not going to find the answers in the order in which they're asked in the question. There's this little formula for finding the line equation for the axis of symmetry, and it's x equals the opposite of b over 2a. Well, if this is ax squared plus bx plus c, then b must be negative 4. So it's going to be the opposite of negative 4. Notice that there's minus a negative 4. Over 2 times a is negative 3. Well, I end up finding that that's 4 over 6, which is 2/3. Okay, so the x value of the vertex is at 2/3. How do I find the y value of the vertex? Well, that's easy. We're going to plug in 2/3 back into the equation everywhere that I see an x. So, first I have to square 2/3. That's 4 over 9. And negative 3 times 4 over 9 is going to be negative 12 over 3, which is negative 4. I could probably just erase that and write negative 4. Minus 4 times 2/3 is 8/3. And then there's a plus 6 at the end. Alright, I need to make a little adjustment. Up here in red, this should have been 4 over negative 6, which is negative 2/3, which means I should plug in negative 2/3 here. That's still going to be negative 4 here, but it's going to change that to positive 8/3. So when I plug that into my calculator, negative 4 plus 8/3 plus 6 is going to be 14/3, or 17, or 14 over 3 is 4.6 repeating. I like to leave things as fractions because they're more exact. So the vertex is at negative 2/3, comma, 14/3. If that's the vertex, the axis of symmetry is the x value of the vertex. So that's the vertex. This is the axis of symmetry. Because the leading coefficient is negative, The parabola opens down, which means the vertex is at a maximum. So the maximum is y equals 14/3. So then the next question is, what's the range? Well, the range are all the y values for which this graph exists. Well, this graph exists. The highest point it exists at is 14/3. And then all the rest of the graph is below it because the graph opens down. The way that we're going to write that in interval notation is we use a bracket to say that it definitely starts at 14/3 or 4.6 repeating, but it goes down forever, and we write that as negative infinity, and we put a parentheses to say that it goes on forever, as opposed to it definitely stops at 14/3, which is why we used a bracket. So again, the vertex, we found out, was at negative 2/3, 14/3. We found that by first finding the axis of symmetry using this equation, x equals negative b over 2a, where a is negative 3, b is negative 4, and c is 6. So we found that the axis of symmetry was x equals negative 2/3. Once we plugged that back into the original equation, we found out what y is, and y was 14/3 or 4.6 repeating. That means that the maximum was at 14/3, and all the rest of the graph is below that. So the range, which refers to the y values of the graph, started at 14/3, which we used a bracket for, but goes downward forever. So we said that goes towards negative infinity, and we use in parentheses. So now let's talk about what is the graph of y equals negative 2x squared plus 2x minus 5. The best way to do this problem is to first identify what a, b, and c are in standard form. Well, in this problem, a is negative 2. Let's make that look more like an a. B is positive 2, and c is negative 5. Once we know what a, b, and c are, then we can find the axis of symmetry. There's kind of an order in which you can find things. We're going to find the axis of symmetry by using that formula, x is equal to the opposite of b over 2a. So x must be equal to the opposite of 2 over 2 times a is negative 2. Negative 2 divided by negative 4 is positive, 1/2. So after we find out what the axis of symmetry is, then on a coordinate plane, I could draw, let's say that's 1 and that's 2, I could draw the axis of symmetry right here because it's 1/2. So I know that's the line that divides the parabola directly in half. Alright, so now the next thing I should find is what the vertex is. And I should determine if this graph opens up or down. So, if the leading coefficient a is negative, the parabola opens down. When it's positive, it opens up. Since it's negative 2, I know that it's going to open down. So that at least gives me an idea of what it's going to look like. Now let's find out what y is. So y is equal to negative 2 times 1/2 squared plus 2 times 1/2 minus 5. And I'm just going to shove that into my calculator to find out what the answer is. 2 times 1/2 squared, no, it's negative 2. Plus 2 times 1/2 minus 5. And my calculator, oops, I did it wrong, hold on. My calculator spit out negative 9/2 or negative 4.5. So now I know the vertex is at 1/2, comma, negative 4.5. So it's at 1/2 and then negative 1, 2, 3, 4, 5. So it must be about here somewhere. And I know, without doing any other work, the graph must look something like this. Now the other thing I know about this graph is that C tells me the y-intercept. So when I'm graphing, I know that the graph went through -5, which was right here. So that gives me a fairly accurate graph of what y equals -2x squared plus 2x minus 5 looks like. I'm actually excited to talk about vertex form because this handout of a textbook we don't have yet has a little bit different way of going about doing vertex form than our old textbook had. And I actually really enjoy this way. I think it's much easier to understand. There is another way of writing the equation of a parabola other than standard form, which y equals -x squared plus 4x minus 5 is in. It's called vertex form. And vertex form is y equals a x minus h squared plus k, where h comma k represents the vertex. And a is going to be the leading coefficient, which we already know is -1. Well, all I have to do now is find out what the vertex is, and I have a way of doing that. I can find the vertex by first finding the axis of symmetry, which is found using -b/2a. So in this particular equation, it's the opposite of b is 4 over 2 times a is -1. So I get -4 over -2 is +2. Now I need to find out what y is for my vertex. And I find that by plugging 2 back into the original equation everywhere I see an x. And I'm going to find out this is -4 plus 6 minus 5. -4 plus 6 is 2. 2 minus 5 is -3. So now I know the vertex is at 2 comma -3. Well, now if I go back to the original equation, I get x minus h is 2 squared plus k, or plus -3, which is the same as -3. A is the initial coefficient, which is -1. So in vertex form, the equation -x squared plus 4x minus 5 must be y equals -1 parentheses x minus 2 squared minus 3. And the nice thing about vertex form is that tells me that the original parabola has been shifted 2 to the right and 3 down, and it's been reflected over the x-axis. And that's what we talked about in section 4.1. Now let's look at a real-world example of a quadratic equation. The Jiaozhou Bridge in China is the oldest known arch bridge, dating to AD 605. You can model the support arch with the function f of x is equal to 0.001075x squared plus 0.131148x, where x and y are measured in feet. How high is the arch above its supports? Well, the first question, how high is it above its support, is asking for the maximum. So in order to find the maximum, we're first going to have to find the axis of symmetry using x equals the opposite of b/2a. And we're just going to shove this into our calculator. So in this case, this is a and this is b. And there is a c, it's just that c is 0. But we don't need it for finding the axis of symmetry. So x is equal to the opposite of 0.131148 all over 2 times a is -0.001075. If you plug that into your calculator, you find out it's about 60.999. We're actually just going to say this is approximately 61. Now that we know x, we're going to find y for the vertex, because the y value of the vertex is going to tell me the maximum, because that's what we're looking for. So y is going to equal -0.001075 times 61 squared plus 0.131148 times 61. And the calculator spits out And we find out that it's approximately 3.999953, which is about 4 feet. So it turns out that these arches are about 4 feet above the support arches, which isn't very far, but that wasn't the point. The point was that the Jiaozhou Bridge was one of the oldest known arch bridges. The next question wants to know why the model, or the equation in Part A, does not have a constant term. In general, this is our standard form of a quadratic equation, and C would represent our constant term. Not only is that the constant term, but that also represents the y-intercept. So why doesn't the equation for this arch bridge have a constant term or a y-intercept? Well, we're not really graphing it on a coordinate plane. You're not graphing the parabola formed by the arch in a bridge on a coordinate plane. So how would I know where the y-intercept really is? There wouldn't be a y-intercept. That equation only represents the equation that models the parabola formed by the arch. That's all we're going to do with it, which is why there's no constant term. And that is standard form of a quadratic function.